My dear student, good morning. I'm going to revise with you now chemical bonding. We are going to study two types of chemical bonding, their electronic configuration, how to draw Lewis structure, and you will give a small brief about the chemical and physical properties of each of those compounds. First, what is a chemical bond? Chemical bond is a force that holds two atoms together. As you know, the atom contains particles. Some of them are positive, some of them are negative, and some don't have a charge. Between those particles, there should be forces that hold them together. The force that holds two atoms together, we call it a chemical bond. How the atoms can form chemical bond? The atoms makes a chemical bond by loss or gain of electrons or by sharing of electrons. So the atom either lose or gain electrons to make a bond or share their electrons. What kinds of electrons that are going to shared or gained or lost by atoms to form molecules? These are only valence electrons. That's why in the next slide you are going to learn more about what are valence electrons. Also, in this video, you are going to learn about the two types of bonding, ionic and covalent. You are going to distinguish between them in terms of type of elements involved and movement of electrons. In this regard, we define ionic bond as electrostatic force of attraction between oppositely charged particles. It occurs between a metal atom and a non-metal atom. It involves loss and gain of electrons. Metal atom loses one or more electrons to be stable, while the non-metal atom gains those electrons that are lost by the metal atom to be stable. On the other hand, covalent bond is a chemical bond which results from equal sharing of electrons. It occurs between two non-metal atoms. And then you will learn the difference in general properties of ionic and molecular compounds. The molecules that are formed from ionic bond, we call them ionic compounds, while the ones that are formed from covalent bonds are known as molecular compounds. What is the difference between both? In ionic compounds, most of them are hard. They have high melting and boiling points. They are poor conductors, means they don't conduct electricity when solid, but conducts when in solution. So if you dissolve an ionic compound in water, it's going to conduct electricity. Also, ionic compounds are soluble in water. Molecular compounds, they are soft, they have low melting points and boiling points also. They are non-conductor, even if they are molten or in solution, and they are insoluble in water. These are general properties. Of course, there are some exceptions from both categories. And then you will learn how to draw electron dot structures of different ionic and molecular compounds, limited to formation of NaCl, KBr, MgO, CaO, MgCl2, Al2O3, and the molecular compounds such as carbon dioxide, water, H2S or hydrogen sulfide, HCl or hydrogen chloride, C2H4 or ethene, NH3 or ammonia, CH4 or methane. You have studied earlier the periodic table, and you know that the periodic table is divided into periods and groups. Elements in the period and groups are arranged according to their atomic number. So if we discuss period 1, we do have two elements, hydrogen, and helium. If you go to period 2, we have 8 elements in period 2, starting from lithium, and then we have beryllium on the left hand side. On the right hand side, we have boron, carbon, nitrogen, oxygen, fluorine, and neon. Period 3 starts with sodium, and then magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Those elements are arranged ascendingly of their atomic number. So we have here an element with atomic number 1 and the mass number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 11, 12, 13, 14, 15, 16, 17, and 18. What do we mean now by stable element or stable atom? Stable means outermost shell is full of electrons. We have only noble gases, those groups, that have complete outer shell, helium, neon, and argon. While other elements in the periodic table, they have incomplete outer shell, and they are seeking stability. How they can gain their stability? By gaining or losing electrons to be similar to the electronic configuration of the nearest noble gas. Let's take an example. Elements in group 1, 2, and then group 13, or now we can call it group 3, 14 or 4, 15 or 5, 16 or 6, 17 or 7, 18, sometimes you call it group 0 or group 8. Elements of group 1, all of them have just one electron in their outermost shell. Elements of group 2 have 2 electrons in outer shell. Elements of group 3, they have 3 electrons in outer shell. Of group 4, they have 4. Of group 5, they have 5. Of group 6, have 6. Of group 7, has 7. And of group 8, have 8 or 0. We have some exception here. Helium, which is in group 1, its atomic number is only 2, means that the element has only 2 electrons. So the outer shell here has 2 electrons, but it's an exception. While any other noble gas has 8 electrons in outer shell. While other elements have electrons that are equivalent to their group number. So how those atoms reach their stability? If the element has 1 electron in outer shell, so it's very simpler for this element to lose electrons, because the element which is located here has 8 electrons in the previous shell and then 1 electron in the outer shell. If the element loses this electron, now it will reach the stability of the noble gas preceding it. The same case will happen if an element has 2 electrons. It's going to lose 2 electrons. If the element in group 3 will lose 3 electrons. If in group 4, okay, normally they don't make ionic compounds, so they are not losing electrons, but they are going to share. Share how many? Now, if the element has 4 electrons and is looking for 8, so this element needs 4 electrons to be stable, so it's going to share 4. If the element in group 5, so it's going to gain 3 or to share 3. If the element in group 6 it will gain 2 or share 2. In group 7, will gain 1 or share 1. So, if the element lose or gain electron, the element will make an ion. Ion is an atom which has lost or gained one or more electrons. So if we said that elements in group 1 will lose 1 electron and they make an ion with plus 1 charge. In group 2 will make an ion with plus 2 charge. In group 3 they will make an ion with plus 3 charge. If you say plus, plus means lose. Don't forget, plus means lose. So the elements in group 1, 2, 3, they will lose electrons. What do they have in outer shell? And form positive ion. In group 4, they will share 4. It's not a gain or loss here, it's sharing. Element of group 5, in order to be 8, it will gain 1, 2, 3. So it will gain 3 or share 3. Here, minus 2, minus 1, and 0 because it doesn't share or gain or lose any electrons. So the element that gain electron will make a negative ion. Now we need to learn more about structure of the ion. Let's draw an atom and an ion of some elements. First, if we have oxygen. Oxygen, it look for the period and group in period 2 and group 6. If in period 2 and group 6, this means that this element has 2 shells because the period number, as per the previous video, the period number equals the number of shells. If the element oxygen lies in group 16 or 6 and in period 2, here is oxygen. So it does have 2 shells full of electrons. They have electrons. So oxygen, first shell, the atomic number of oxygen is 8. So it has 2 electrons in the first shell and 6 in the outer shell. And this is the positive nucleus. This is the structure of the atom. When oxygen is, remember, in group 16, keep the periodic table in front of you. Group 16 means it does have 6 electrons, going to gain 2 electrons. So oxygen will gain 2 electrons from any other atom. So it will gain means I will add to it 2 electrons. So it will make an ion. The ion now normally the atom was having 2 electrons here in the first shell and 6 electrons, 1, 2, 3, 4, 5, 6. It's going to gain 2. So now it will have 8 electrons in outer shell. The atom normally is neutral. Any atom is neutral, has equal positive and negative charge. If oxygen has atomic number of 8, means it has 8 positive protons and 8 negative electrons. And the total charge is 0. Now, atom has gained 2 electrons. So I do have 8 positive protons, but I will add to them now 10 electrons because the atom will gain 2 more electrons. So what will be the final charge? As the electron is negative, so it will be minus 2. 8 minus 10 equal minus 2. So now the ion will have a charge of 2 minus. If this atom, we call it oxygen, the ion we call it oxide, and this is what usually we say for nonmetals. If sulfur gain electron, it will make a sulfide, chlorine make chloride, iodine make iodide, hydrogen makes hydride, and oxygen makes oxide. Let's take another example from metal group, calcium. Calcium, its atomic number is 20. Calcium. It lies in period 4 and in group 2. Period 4 means there are 4 shells. So we have the nucleus, and the nucleus is surrounded by 4 shells. They all have electrons, while the outer shell only has 2 electrons. Here we don't need to draw the 2 shells or the 3 shells or 4 shells. It's enough just to draw the electrons in the outer shell. So I will draw the 2 electrons that were in the outer shell and write calcium. So calcium has 2 electrons in outer shell. What will happen? Calcium is a metal, and we said that elements that are on the left hand side of the periodic table in groups 1, 2, 3, they are going to lose electrons. So this element has 2 extra electrons, these 2 electrons, it's going to lose them. So I will write minus 2 electrons. If calcium loses 2 electrons, it will make an ion with 2 positive charge. We need to learn more about this. Calcium has an atomic number of 20. Means this atom has 20 positive proton and 20 negative electron. When the atom loses, because you are going to take from calcium 2 electrons, so now the number of electrons will be only 18. So I have 18 negative electrons, and we have now still have 20 positive protons. So what will be the net charge here? 20 minus 18 equals 2. So calcium will have an ion with 2 plus charge. Now you can practice drawing ions. Keep the periodic table in front of you to be able to do that task. Let's take some elements. I will write examples of some elements: sodium, silicon, phosphorus, nitrogen, chlorine. Before you start to do anything, look at the position of the element in the periodic table, recognize its period number and group number. By looking at sodium, you will recognize that sodium lies in period 3 and in group 1. Silicon in period 3 and group 4 or 14. Phosphorus in period 3 and in group 5 or 15. Nitrogen, period 2 and group 5. Chlorine, period 3 and group 7 or 17. Next, you need to draw the structure of the atom itself. To be able to draw the structure of the atom, write the element Na, write its symbol, okay, and then write the number of electrons in the outer shell. Number of electrons is the group number. Group number is number of outer shell electrons. Okay, the number of electrons in outer shell also we can call them valency of the element or valence electrons. Valence electrons. Valence electrons here are 1, 4, 5, 5, 7. valence electron or number of outer shell electrons have the same meaning. Valence electrons or outer shell electrons. Then, what is the valency? Valency is the number of electrons that the atom, valency, number of electrons that the atom gained or lost to be stable or to reach the structure of the noble gas. Electrons gained or lost. We said elements in groups 1, 2, 3, they will lose electrons 1, 2, 3 respectively. So if an element in group 1 and has one valence shell, it will lose one electron and its valency here will be +1 because it's going to make an ion with +1 charge. Silicon in group 4, it doesn't make ion normally, but if it does, it will have a valency of 4. Phosphorus in group 5 and has gains 3 electrons to be stable, to be 8. So the valency here is -3 because it will gain 3 electrons making a negative ion. Nitrogen in group 5 also it will gain 3 electrons to make a negative ion. Chlorine in group 7 and it will gain -1 electron and make an ion with a charge 1-. What's left now is only drawing. Because you already now understood the valency, position of the element, how much the electron does the atom need to gain or lose or share to be stable. So now we need to draw the atom and its ion. Atom Na, it has 1 electron, just draw it, draw a dot. The ion, it will lose this electron, so the charge will be like this, 1+. The valency is a charge. Here, silicon, it has 4 electrons, 1, 2, 3, 4. Normally, it doesn't make ion, so I'm not going to draw it here. Phosphorus, P. How many electrons in the outer shell? Or the valence electrons are 5. So draw 5 and draw them in a systemic order. 1, 2, 3, 4, 5. To make the ion, the atom is going to gain electron. If the atom gains electron, you should draw the total number of electrons. We were having 5 and we will add 3 to them. 1, 2, 3. The charge will be -3 or 3-. Nitrogen, also 5. 1, 2, 3, 4, 5. And it will gain 3. So draw N with the 5 electron and add 3 to them using another symbol or another color. 3-. Cl has 7 electrons, 1, 2, 3, 4, 5, 6, 7. It will gain 1. 1 to gain means 6. So I'm going to add. You will add 1 electron here and make an ion with charge 1-. Remember, this charge is the valency of the ion. Okay? And this drawing, we call it Lewis structure. Lewis structure of the atom or of its ion. As you know, we said that the chemical bonding are divided into 2 types, ionic and covalent. We are going to start with ionic bonding. Ionic bonding means bonding which involve ions. Those ions are either positive or negative ions. Once the ion is formed, there will be force of attraction between the positive ion and the negative ion. This force of attraction, we call it ionic bonding. And the attraction that happens between charges, oppositely charged particles, we call it electrostatic attraction. So ionic bonding is electrostatic attraction between positive and negative ions. You have learned now how to form an ions. Now, how to make the bond. To make the bond, we just need to make the ions that are the electrons that are lost from one atom equal to the electrons gained by the other atom to balance the charges. Once they are balanced, they will attract each other and form the bond. If you have an element Na from group 1 with Cl which is from group 7, how they bond? First, sodium will lose electron, form a positive ion with a charge 1 plus. Cl normally it has 7 electron outer shell. It's going to gain this electron to have 8. One, two, three, 4, 5, 6, 7, and you will add the 8 electrons. Now Cl is a nonmetal atom and it will make a negative ion. This is the ionic bonding because simply they will attract together making a bond. Let's take another example. Mg and O. Look in the periodic table. You'll see that magnesium lies in group 2. It has then 2 electron outer shell, while oxygen is in group 6 or 16 and it has 6 electron in outer shell. For magnesium to be stable, it's going to lose, because it's a metal, so it will lose the electron, 2 electrons, and form a positive ion. Oxygen, it has 6 electrons. It will gain the 2 electrons that are lost from magnesium to make an ion with 2 minus charge. This ion, we call it oxide. The name of the metal doesn't change. We change only the name of the nonmetal. So the name of the compound is magnesium oxide. Here, sodium and this chlorine will change into chloride. So this is sodium chloride. Example 3. Magnesium and Cl. Magnesium, look in periodic table, it's in group 2, has 2 electrons. Chlorine in group 7, it has 7 electrons. How those atoms bond? They will make ionic bonding because one of them is a metal and the other is a non-metal. One is on the left side and the other is on the right-hand side of the periodic table. Remember that ionic bonding is usually formed between a metal atom and a non-metal atom. One on the far right side and the other on the far left side. Magnesium will lose the electron and make a positive ion. It doesn't have any other choice. It should lose 2 electrons together to be stable. While Cl, it needs how many? Yeah, count 7. So how many electrons are required? Only 1. So Cl is going to gain 1 electron, which is lost from magnesium. Remember, number of electrons lost should equal number of electrons gained. So here, magnesium has lost 2 electrons, while chlorine cannot gain 2 electrons. It can gain only 1 to make an ion with minus 1 charge. And we have just said that the number of electrons lost should equal the number of electrons gained. Magnesium should lose 2 electrons, chlorine should gain 1. So you need to use another Cl atom to gain the second electron. making two Cl ions. What we call this compound now? Magnesium chloride. Example 4. A bond between K and Br. K is in group 1. It has 1 electron in outer shell. Br in group 7 has 7 electrons in its outer shell. How do they bond? A metal, a non-metal, so an ionic bond. How the bond will be formed? Via making ions. Potassium will lose its electron, making an ion with a charge 1 plus. Br will gain this electron, making an ion with minus 1 charge. What we call this compound? Potassium. We call it bromine. We don't change the name of the metal as I told you. So it's a potassium. But the non-metal, we should change the N with D in the suffix of the name. So we'll call it potassium bromide. Example 5. Calcium oxide. Reaction between calcium and oxygen. Calcium, yes, group 2, and it has 2 electrons. It's a metal. Oxygen lies in group 6, has 6 electrons in outer shell. A non-metal, oxygen. How do you bond? Lose and gaining of electron. Calcium will lose 2 electrons to be stable, lose its valency electrons, making an ion with a charge 2 plus. We call it calcium ion. While oxygen will gain, how many electrons does oxygen need? It needs 2. So it will gain 2 because it has 6. In group 16, just 2 atoms to reach the structure of the noble gas. We call it here oxide. So the compound is named as calcium oxide. Another example, aluminium oxide, Al with oxygen. If you look at Al, it's in group 3 and it has 3 electrons in the outer shell, a metal, and we call it aluminium. Oxygen, on the other hand, it's in group 6, a non-metal, in group 6 and has 6 electrons in outer shell. In order to make a bond between them, aluminium should lose 3 electrons and make a positive ion. Look at the structure of the ion first and don't worry about the number. We'll rebalance the number later on. It will make an ion with a charge 3 plus, aluminium. Oxygen, it has, as we said, 6 electrons. 1, 2, 3, 4, 5, 6. How many does it need? Yeah, it does need 2. So it will gain 2 and form an oxide with a charge 2 minus. We need to balance the number of electrons gained and lost. We have an atom here which has 3 electrons in the outer shell. Aluminium has lost 3, but oxygen can gain only 1. Okay, so what will happen? How to balance? Very simply, This is 3 and this is 2. So the common factor, the least common multiple between 3 and 2 is 6 to make either side 6. So aluminium has 2 electrons, use 3 aluminium atoms. So now, it has 3 electrons, 3 into 2 equals 6. So we use 2 aluminium. 2 aluminium means aluminium. Now the 2 aluminium will lose 6 electrons. Oxygen. The oxygen atom can gain 2. So in order to gain 6, we need to use 3 oxygen. 3 oxygen, they are going to gain, each one will gain 2, so the 3 oxygen atom will gain 6. So now the number of electrons lost equal the number of electrons gained. Gained are 6 and lost are also 6. Okay, don't forget to balance, right here 2 and right here 3, and this is oxide, aluminium oxide. If you are asked in any exam to write formulas, you need to give those formulas. This is what you will be asked about. Let's look at those questions and try to solve them. Question 1. Draw electronic dot structure for each of the following compounds. The very thing you need to do when you encounter a question like this is to recognize the type of bond. How can we recognize the type of bond? By looking up the first element. If the first element is a metal, so the bond will be ionic. How can I know is it a metal or not? Look up the element in the periodic table. If it's in groups 1, 2, 3, or any of the transition metals, so it will be an ionic compound. Here, potassium in group 1, ionic bond. Magnesium is in group 2. NaCl, Na, sodium in group 1. So it will be an ionic bond. Calcium in group 2, ionic. Magnesium, as we just said, ionic because it's a metal. Aluminium in group 3, it's a metal also, so the bond should be an ionic bond. Other examples are for covalent compounds. Carbon is in group 4, so it's a nonmetal. If nonmetal, the bond will be covalent. We'll discuss covalent in the next video. Hydrogen is in group 1, but it's an exception. Group 1 includes alkali metals, but hydrogen is a nonmetal there. It's an odd element there. So the bond here is covalent. Covalent. Here, N is in group 5, covalent. Carbon in group 4, covalent. And here also covalent. Now, how to show the bond in ionic compounds? NaCl, sodium chloride. Draw sodium with its electron and draw Cl with its electron. 1, 2, 3, 4, 5, 6, 7. One electron is going to move from sodium to Cl. Sodium will lose an electron and Cl will gain an electron. So finally, sodium atom will remain without electrons, forming a positive ion of a charge 1 plus because it has lost only one. Cl is going to gain this electron and acquire a charge 1 minus. This is the electronic dot structure. KBr. K is in group 1, Br is in group 7. So K has 1 electron in outer shell and Br has 7. Also, 1 electron is going to move from K to Br, making both of them stable. So the electron will move it from K side to the Br side, Br will acquire a negative charge, and potassium will have a charge 1 plus because it has lost one electron. MgO. Mg, magnesium, has 2 electrons in outer shell. Oxygen has 6 electrons. 1, 2, 3, 4, 5, 6. Oxygen needs 2 electrons to be stable, and magnesium should lose 2 electrons to be stable. So the 2 electrons will move from the magnesium side to the oxygen side. Magnesium will acquire a charge 2 plus. Oxygen will gain the 2 electrons and will acquire a charge 2 minus. CaO. Calcium in group 2 and has 2 electrons in outer shell. Oxygen in group 6 and has 6 electrons in outer shell. 1, 2, 3, 4, 5, 6. Also, for both atoms to be stable, 2 electrons will move from calcium side to the oxygen side, or from the metal side to the non-metal side. We remove those electrons, and calcium now becomes a positive ion with a charge 2 plus. The electrons that will be gained by oxygen, making it an ion with a negative charge 2 minus. MgCl2. From the formula, you'll know how many atoms you are using. Here, we have 1 magnesium and we have 2 Cl. So just draw 2 Cl. Draw the electrons around the Cl atom. Cl has 7 electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Magnesium initially has 2 electrons in outer shell because it's a metal and it lies in group 2. Those 2 electrons, one of them will go to either of the Cl atom. So now magnesium becomes an ion with a charge 2 plus because it has lost 2 electrons, while each of the Cl atom will acquire this electron and become an ion with a charge 1 minus. Each atom gains 1 electron only. Al2O3. Okay, it's very clear to you that we use 2Al and 3 oxygen. Al, initially, it has 3 electrons in the outer shell. Each Al has 3 electrons. Oxygen has 6 electrons in outer shell. So each oxygen has 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. As you know, the metal atom will lose all its valence electrons. So aluminium will lose its valence electrons. The 3 of them will be removed, and the other atom also. So now 6 electrons are lost. Those 6 electrons should be gained by the 3 oxygen atoms. So each oxygen atom will gain 2 and becomes stable. Aluminium, which lost 3 electrons, makes an ion with a charge 3 plus. While each oxygen, which gained 2 electrons, will have a charge 2 minus. Okay, now you understood how to draw Lewis dot structure for ionic compounds. In the next video, we'll explain covalent bonding. Thank you.